Okay, thank you everyone for staying along with us and joining our panel. So we are starting our Sovereign AI panel, the case for building out your own. Over the past few years, different countries have been developing their own sovereign AI capabilities, and there has been different approaches discussed, like whether you pre-train from scratch your own model that knows your own language and your cultural things, or whether you fine-tune an existing model from the open source community that, let's say, speaks English. So today, I'm so excited to have a discussion with experts in the field, representing different countries and talking about how they approach sovereign AI. So give them a round of applause, and we will start with the intros. Natalia, do you want to introduce yourself?
Hello? Okay. I'm Natalia. I'm with the Cerebras. I'm Vice President and Field CTO at Cerebras, and I oversee all technical engagements with our customers. And part of these is training different models with customers and for customers. And I've alluded at the beginning of the workshop, we've done several projects on training regional specific and culturally aligned models with different collaborators, including some of them are sitting here in this panel. So we got exposed into different challenges and opportunities of training those models, but also for me, again, sovereign AI, it's not only about models that speak your language, it's way more than that, and I want to discuss that with all of you.
Hey, thanks for inviting. I'm Hrant. I'm leading a research lab in Armenia, in Yerevan State University and Yerevanen. We're working on AI for molecular discovery, and another part of the team works on robotics applications.
Hi everyone, it's lovely to be here. So my name is Sarah Hooker. I have done my tour of duty at different Frontier AI labs. I was at DeepMind, and then I led the research arm at Cohere Labs. And now we have just started Adaption, which works on incredibly efficient intelligence that evolves with the world. Maybe interesting for this conversation, I'll just share a few pieces. A lot of my work has been how do you build technology for the world. So when I was at Cohere Labs, we worked a lot on building models that extended the reach of languages, both multimodal as well as language. We released Aya and Aya Vision, which doubled the number of languages covered. So I actually, perhaps what may be interesting is I feel like I've both encountered every challenge of building technology that works well for every language, as well as the meaningful parts of seeing how introduction of technology can change how people use it. So there's probably some fun topics there. But let me pass on. Here we go.
Yeah. So my name is Preslav Nakov. I'm professor in Department Chair of Natural Language Processing in Mohammed bin Zayed University of Artificial Intelligence. And I also work with the Institute of Foundation Models, which is part of the university, which has branches now in Paris and also in Silicon Valley. And we have been working a lot with Natalia and her team with Cerebras to train a variety of large language models. So we start with JACE, and actually JACE is an entire family. And there are several iterations, and they're kind of models up to 70 billion parameters, like trained from scratch. And we have been building other models, like for Kazakh language, for Hindi, so, I mean, we have also encountered the problems that are there. And one thing that I want to say is that actually it's something unique, because typically those models of these sizes are only possible to build in companies, right? There's kind of no other research institution that has built anything of this size. And the other thing is actually kind of Hector Liu spoke earlier here. The models are actually kind of fully open, some of them, right? The K2. They are not just open weights, they are also open data, open code, even open code to generate the data, and even the checkpoints are there, and the thinking model is of the same level kind of transparency. But yeah, so back to the thing of the sovereignty, it's really important to kind of, it starts with the data. Even the English data actually reflects the local culture.
Hi, I'm Ryo Yokota. I'm a professor at the Institute of Science Tokyo, and also I lead a team for AI for Science foundation models at RIKEN. I'm involved in various projects to train foundation models in Japan. There's a model called LLM-JP. We've been training for quite a while now. The largest one we've trained is a 172 billion parameter model from scratch. Also, we do continual pre-training from models like Qwen3 and GPT-OSS at Japanese, and without losing math and code capabilities. And so we do a lot of continual pre-training too. I think it's very important to add new cultural, like Japanese culture data into these models, because there's very subtle sort of subtleties in the Japanese language that make the interface of default English-based LLMs not so polite enough to the Japanese users. In the business scene, it's really important that they get these formalities right, and these things are really important. Also, we want to preserve our culture and also have the capability to train these models somewhat, for larger models, and to have continuous development in Japan. We are continuing these efforts with the small amount of resources that we have compared to the US. But we also have collaborations with DOE labs. I'm originally from the high performance computing field. We are looking to bigger allocations on the US DOE lab machines, and they're going to be acquiring or purchasing a huge amount of compute. And we look forward to further collaborations with them as well.
Hello, thank you for having me here. My name is Kuno Choi, and I represent Upstage LLM or AI startup in Korea. I used to work a lot more on audio and music AI before in companies like Spotify and TikTok. And later I moved on to join LLM and also Genentech, the pharmaceutical company in the US, where I led a team to train and deploy a large language models for scientific applications, especially focused on the biomedical applications like drug discovery and protein modeling and things like that. More recently, I joined Upstage, and about the importance and the sovereign AI. A lot of you already covered them, and I just want to say I totally agree with all of the motivation, and that's also why I joined there, and where my teammates are working on the large language models for developed from scratch from Korea, and based on because of my background and etc., I think I will also work on the speech language model, which will also have some more focus on the regional aspect and languages. Yeah, that's it.
Thank you for sharing. So the next question I have for you guys is maybe the most complicated question in the panel. How do you define sovereign AI? What's, in your opinion, sovereign AI means? Natalia, do you want to start? Sure, yeah. Kunwu, do you want to start?
That's a surprise.
You get the most complicated question first.
I want to tweak the question, especially because I don't have time to reason about this. I want to avoid the question by sharing my opinion about not a definition of sovereign AI, but maybe my spiciest take could be nearly every AI is actually sovereign AI. Yeah, that's what I want to say, because thinking of, I don't know, say Google. Is Google 100% non-sovereign AI? And that's hard to say, right? Because there's some aspect there. So that's what I want to say. Yeah.
So basically, sovereign AI just means AI.
It's one aspect of the every AI company, I think. Yes.
Okay. Ryo?
I think it's very difficult to define exactly what sovereign AI is. I think it's more like a political term now that governments tend to throw around, to actually, what they actually want to do is to invest in, the AI technology in their own country. The model itself is not, their main goal to develop. The model is like a byproduct. I think a lot of the sovereign AI efforts are aimed towards maintaining and also acquiring this kind of technology to develop these AI foundation models within the country and not depend too much on foreign technology. I think that's sort of the real objective of sovereign AI.
So sovereign AI more like independence from other countries. For a given
Technological
country.
independence. I mean, there's also this let's train a model that understands our culture kind of aspect, but I think there's another aspect of having the technology within the country. It's, yeah.
Being polite as well.
Yeah, and being polite if you're a Japanese AI.
Thank you, Ria. Veslav?
Well, I also think that it goes beyond the model, right? It's really, it's basically to have the capability to, to be basically sovereign means independent, right? That kind of you have the capabilities to do it with whatever resources, kind of internal resources to the country. This means that, well, it really kind of requires the electricity, requires the compute, right? But also requires the use of this, right? Kind of you should be able kind of to serve it. You should also have kind of the kind of people, the kind of companies that are ready to use it, so that you are not really dependent on I don't know, kind of like people have been thinking. I mean, kind of why you need it, right? Maybe I can go kind of a little bit further. Why? Well, I can give you several examples, right? So WAMA, the latest WAMA model is not available in the European Union, right? So those kinds of things can happen. You can be kind of left out, and if you have been developing systems, imagine, right? And then you have developed models on top of some kind of systems on top of certain model, and then the model somehow, or the model can be retired, right? Maybe you have something and you have the prompts in something that is really, really working on specific version, and then the provider just retires it. What do you do, right? And again, okay, you might want to have something open weights, fine, good, but it also has to run. You need to have the energy, you need to have the servers, and you want to make sure that, again, somebody cannot stop it, or there's sometimes drama in some of those big companies, who is on the board and all these kind of things. You don't really want to be dependent on those things. Yeah.
So maybe to summarize, sovereign AI is more about staying relevant, right? Okay.
I think sovereign AI is it means a lot of things to many people. It's kind of like the data for good moment that happened, where it's a very imprecise term. But maybe for me, it's the ability to participate in breakthroughs, which I think is very critical. There's a Stanford Index report which comes out every year, and there's a fantastic chart which basically codes over the last 20 years, where have machine learning breakthroughs come from? And Latin America is not coded, Africa is not coded, Asia, it is China. So the question, we're in this room on Friday at 7 p.m. in San Diego, but there's many parts of the world that are not represented here, right? And so we're at the edge of what's possible. Sovereign AI is really about how do we, in my mind, the models are the byproduct of it, but it's building up the muscle to participate, a lot of it. And so frankly, that's also my interest in it. I think as a byproduct of building up the technical capacity as well as the hardware to do so, you end up doing, apologies, that was my alarm for solving AGI. So I think that's what's interesting about it. But I do think it needs to be more precise. The way it's thrown around now, it means everything from motivating more investment to motivating the quality of the end product. So hopefully we can get more precision there to understand also accountability is important. When is sovereign AI returning on the investment, and when is it not? Yeah.
Great, thank you, Sarah. So to summarize, it's more about the muscle, right? So when you build sovereign AI, you build the tools to be able to continue being relevant, I guess.
I agree with Sarah that different people have different meaning behind this word. I think initially the term was invented by chip companies to sell more chips to governments. And now it's slowly starting to get meat or meaning behind that, right? So to me, like one kind of a practical application or practical form of sovereign AI would be if one of the governments in the world figures out how to deploy AI in a way that it increases the efficiency of public sector, like truly serves the citizens, truly serves the country, and it is independent enough from other countries. So that could be like a good application and something that satisfies the premise under the term of sovereign AI. I don't think it's happening yet, but I expect that it will happen sooner or later. It can serve the public sector, it can serve the education system. So there are many things that you want to have local and independent, but I'm not sure it's happening now. So far it's mostly about marketing.
So basically, you're similar to Rio's opinion that it's more about independence when you build sovereign AI projects. Okay, thank you.
So as a representative of a chip company. Did you invent that? No, we did not invent that. I do think that it's definitely more than the models and maybe the narrative of muscle and tools and independency. It resonates with me. To me, it's also a lot about developing talent in local countries who will be able to reproduce and to develop new tools that leverage this new type of technology. So you want every single country, and it's normal, they want to be able to leverage whatever is available with new inventions towards the good of the citizens, and you want to be able to do that internally in the country. And for that you need, yes, infrastructure, you need talent and skill sets, and you need data, you need take into account some cultural and other aspects of the region to make sure that the tools that you develop really serve your community. To me, sovereign AI is about that.
Got it. So it's more a broad term, in your opinion, right?
Yes.
So all data, talent, models, and all, and muscles when you build them. All right. Thank you for sharing, Natalia. Next question is to you. So you train, you build models for a lot of customers across the globe, and you either train for them these models for them, or you sell the infrastructure. Could you share with us why it is important for Cerebras as an American company to continue helping other countries build their own sovereign AI?
So I think Hrant already discovered one selfish argument why it's important, because it's a broader market. So for us, if you deploy additional infrastructure worldwide, and especially if you educate users to use your type of infrastructure, that's a long-term business for us, which is good. But I think it's more than that. To me, it's also, I would like the diversity in the community. I think it's good, like it's not a zero-sum game. So if you have researchers in Armenia, researchers in Japan, researchers in Korea, researchers all over the world, where in some places maybe there are not enough skills yet, they will get access to infrastructure, they will get access to exploring, trying, generating new ideas. We all as humanity will benefit from that. So to me it's important to, again, collaboration across the world and empowering people across the world, not only in the United States.
Thank you. And if anyone has any questions, feel free to ask them at the end of the panel or type them in our Q&A on Zoom. Yeah. Thank you, Natalia. That also resonates with me. I feel like together we can build better models, and I think it's all about kind of collaboration, discussing ideas, one of the reasons why we're doing the workshop. I guess if other panelists don't have anything to ask Natalia, I can ask Preslav. Preslav, your team developed the best Arabic-speaking models, and I'm curious, based on your experience, which component of the entire stack, because it's never just the model, it's never just the data, which component is the most important in terms of sovereignty? Is that building data set, building the model, evaluation benchmarks, or is it the talent?
Well, if you want to build a language model, you need several things. So you need data, you need the model, you need the compute, you need the people, the talent, and you also need the vision. You need to know what you're doing it, why you're doing it, right? So, and of course, kind of you also need the, the means to support it, which means that you need also, the money to invest into that, and you might need the energy infrastructure. You might kind of need the, to support this kind of compute, because you might have the GPUs, but not really kind of the center to do it, and so on and so forth. But of all of these things, actually, if you think about it, this one, I mean, somebody was saying that if something can be bought with money, it's not. If a problem can be solved with money, it's not a problem. It's an expense, right? Now, the thing is, okay, let's think about, right? Imagine you have enough money, okay? Which of those is the bottleneck? Well, it's clearly the data, because hardware you can buy, right? Okay, they can buy also export control and this and that. It's kind of, there's a lot of demand, but you probably can buy. People, you can probably even buy from somewhere, or you can train, right? And you can invest and you can train more. But data, practically, there's not enough data. And the data, all the data that is available is already exhausted. So basically, there's no public data that you can grow anymore. That's even true for English, and imagine for some other smaller languages, right? So, yeah, that's the main thing, right? And then when it comes to data, right, if you're building, let's say, Arabic model, there are many subtleties there. So one is about the Arabic language, but then it's really kind of, it resembles a language family, because they kind of many different variants. They are kind of dialects, these kind of, also kind of things in social media and this and that. Some of the data is not clean. That's one. But the other thing is, you never train a model. Okay, maybe you do, but I wouldn't, right? You never train a model just for one language. You typically kind of want it to be bilingual. You want English there. Why? Well, for many reasons. One is people going to want to translate, right? Well, if it's going to translate to what? To English, okay. Actually, we built a model for Kazakh language, right? There, we had to do, in addition to English, we had to put also Russian, because it's like, commonly used there, right? So kind of you probably, if you're building something for Arabic, maybe you want also French there, right? And kind of maybe also dialects. So kind of it's more than one language. But now, if you think of English, right? It's again not enough just to go. There's a lot of publicly available data. Actually, like we had like Hector Liu here spoke about the TXT360 corpus, 15 trillion tokens. 15 trillion tokens are available already for English, right? So there's a lot of data, but it's not the same data that you would have when you're building an Arabic model. Why? Well, maybe you go there and you make a contract with the local news agency, right? And so when you think of a model, you're thinking of the language, right? And maybe the culture that's embedded in the language. But when it comes to sovereignty, it's also about which language, right? Even English, it's spoken in many different countries. If I train a model on American data, it's one thing. If I train it on the British data, it's going to be different. So if I train it on English data from the Middle East, it's going to have different kind of understanding of the world, different view on maybe historical events, political events, different kind of knowledge about the local geography, who is this, who is that. So what I'm saying is, it's not just about the language, right? It's also kind of the country where this is coming from. That's one. The other thing is that when you're tuning the model, for example, for Arabic, there are several models for Arabic that are being built, and actually different, and it's true for other languages, kind of, the designers there might have different priorities, right? For some of them, maybe your priority is like, I want a model that is neutral, right? Or maybe I want, that is neutral, right? Kind of, that is kind of, and actually our model is like that. Our model is a very good politician. You ask it something very, very kind of, I don't know, kind of tell me something bad about this politician or something. And I say, yeah, or kind of about this country. Kind of, I say, yeah, kind of there has been this criticism, but this, and kind of you have to inform yourself to find a balanced view and blah, 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 like ChatGPT style, kind of, very good kind of, smooth. That's not always the view that, kind of, sometimes kind of you want to have a certain point of view and yeah. So I would say, yeah, it's about the data, but it's also kind of the values of the people that are developing the model. Anyway, super long answer. The short thing is the data is the most important thing.
Okay. Talent.
And-
To me, talent and vision is the most important thing because if you have talent, you will find a way how to either find the data or find the ways how to deal with very limited data. That's my 2 cents.
I agree because if you have a people and talent, you can get the data. If you have a data without people, that doesn't probably bring. Data doesn't do the work to grow people. It's a very extreme view, right? Because in the real world, it's not like hard decision, right? It's just about like which one and how much weight you put it. But then I think if I have to rank it, it's the talent because they can do things.
One recipe for solving the problem with data is to use Gemini to translate the English to whatever language you want, I think.
That might be against their terms of service.
I tend to disagree. So kind of in the first JACE version of JACE, we actually kind of we had about maybe 3 billion tokens. No, actually we had more. We had like several billions of tokens. Basically translated the English Wikipedia to Arabic, right? That's what we did. I think it was about 3 billion tokens of translated data. And we had some others. Anyway, okay, we have a few billion tokens of translated data, and eventually we regretted it because it was generating things that were showing signs of translation. Because translation is you kind of you feel it, right? So I mean, I'm always kind of very nervous about translated data in a decoder-only model, right? If it's in encoder-only model, like something like, BERT style, you can do whatever you want, right? It's fine. But if you are generating something that's, you can also introduce hallucinations and all that. I mean, don't get me wrong. I like synthetic data. We are actually kind of, doing also translation. But translation for the pre-trained data, I mean, translation maybe for evaluation, again, it's not the best way to do evaluation data set, but if you have nothing, can be a good way to start. I mean, but just to start. Actually, you want translation really kind of natively in the language. Evaluation is really in the language, but okay. Translation for instruction tuning, again, it's better to have like native one, but it's fine. You can do it there. But in the pre-training, I'm very nervous about that.
Thank you. Thank you, guys, for discussing this topic. So it seems like Preslav also mentioned that it's better to build models that speak multiple languages. So my next question is to Sarah. I know you researched a lot low resource languages, and Aya, for example, it speaks multiple languages, so just one model that speaks all of them. However, we still see countries sort of developing models that speak their own language, so there are separate models, not one giant model that speaks all of them. What do you think about this research perspective? Is it better to build separate models for separate cultures and languages, or is it better to build one that speaks all of the languages?
It all depends on really how. So there's a few things. One is that there's a curse of multilinguality. So there's only so far you can go. This is a curse of capacity. So our models typically have finite capacity, and you need to balance how you use that capacity. Aya was a great example. There's Aya 101, which covered 100 languages. This model is probably at the extreme limits of capacity. There's Aya 23, which was released after, which was state of art in all 23, because that's using that capacity for 23 languages. It's less strained. In fact, a lot of, I would say, that tipping point is interesting to understand, because up until that tipping point, you benefit from more languages. I think this came across here. You develop, there's transfer between different language families, so you exploit that. It also depends very much on your quality of data, which came up in a theme. So typically when you do pre-training, you still keep the majority of your language, your first-class citizen languages, mainly because of quality of data and diversity of topics that are covered in that data. So in most of the treatment of that tends to be European, English, Chinese, Japanese, essentially languages spoken by large volumes and populations of people who have been using the internet for a long time. So you can see in terms of access to the internet, that's who dominates the footprint of the internet. And so that's going to be in your mix. A low resource, in fact, so much of what you're trying to do is exploit post-training dynamics to achieve good representation for those languages. How you exploit that, I agree, it's about talent. So for your low resource languages, it really matters, do you know how to optimize for rare artifacts in the long tail? Our models are not particularly good at learning the long tail, right? We have very expensive learning mechanisms. Part of why we use so much compute is that we spend the first part of training very easily learning what's frequent, and then we spend most of training learning what's rare. So anything you can do to improve that efficiency is very interesting. You can do it in the data space through synthetic data. That's almost working around the limitations of our models, right? Because we're almost like trying to do things in the interesting synthetic, and there's very interesting optimization algorithms there that again depend on talent, and a lot of the recipes are not shared, right? So that's really interesting. But the second thing is how you do your optimization space in the post-training is also about how do you leverage even your inference time compute. So a lot of what I'm working on now, Adaption, is about no one's going to double the size of their model in the next 2 years. Our architecture is largely saturated. What matters more is the overall recipe. So how do we combine these new optimization spaces to treat more complex problems in the right way? And rare, low-resource languages are very complex problems. So how do you spend your budget? And how do you think about that at inference time? So these are all compelling problems. What that means is that the decision to train your own model, you're going to get a crappy model if you are only training on one language and all your data is rubbish. That's the truth. And you should be actually, I think I see too many initiatives that embark on this project with none of the criteria satisfied of having enough data or enough good quality data and just plunging into it. Is that still beneficial for a country and for an ecosystem? Probably. Yeah, like it brings people together, it builds up, mistakes also build up capacity, so it's probably still worthwhile. But if your goal is to deliver something that actually services a community, which I think was your point and very well said, well, how can we introduce something that serves the public good? You have to acknowledge that you need those ingredients in place. So if you don't have a lot of data, you have to go broad, multi-training. And if your data is not high quality, you better have the expertise. So that's kind of fun. I don't know if people want to add anything, but I think those are nice points there.
To briefly add here, so one aspect that is usually overlooked in language-specific training is that there are many topics on which there is very few data in other languages. Like you can go to extreme, like I don't know, in quantum chemistry, probably there are like 5 languages in the world that you can find content in, right? But even like mathematical reasoning, right? So this entire research on math reasoning is happening mostly on like English stuff. So in order to have a model that speaks Armenian and can solve mathematical problems, like, I don't know, for school children, you need to have a way to transfer the knowledge from English to Armenian. So I think one way, which is, I don't even know how these things are probably done in those big companies, but I think you have to make sure that there is an internal knowledge transfer in the network from English to other languages, and you have to keep the English capabilities very well to support the other language capabilities in those fields, because you can't teach, I don't know, very heavy mathematical reasoning in any other language.
I just want to say I agree. Just too sure, maybe. Like when I was in Genentech and training biomedical language model, it was in some sense kind of easy because we just had to take care of English, because that has all the like papers and academic like books. Now that I am training a Korean language model, now I realize, as everyone said, now I have to probably translate. Yeah, right. That's so that we can cover the distribution of all the knowledge and everything that is covered by the, I don't know, model population or the bigger population, bigger distribution in English probably, to cover all the knowledge.
Thank you. Yes, it seems like, Rio, go ahead.
We've been trying to develop a model that can reason in Japanese, but somehow when you let it reason in English and then the final output just gets translated to Japanese, we get much better answers. So we haven't really found a way to do reasoning in our native language. Well, I mean, it does it, but not at the same performance. So this could be, it's not lack of knowledge per se, because it's not memorization tasks that we're evaluating it on. It's like reasoning tasks. But it seems difficult to do this in a native language. This is something that, maybe someone knows how to do it.
Well, I actually kind of want to say something else, which is many people because typically those languages are, we have been discussing there's not enough data, right? And we're talking about resource-poor languages, right? So what some people say, well, look, I don't have data, I'm going to train something small, right? I'm going to kind of train, a small model, like, I don't know, 1 billion, 2 billion, 3 billion parameters, or, because I don't have data, right? Okay, well, maybe you can do synthetic data, this and that. Well, actually, wrong. You need a bigger model. And actually, the less data you have in the language, the bigger model you need, right? Why is that? Well, I mean, and they're kind of, we have seen that ourselves. We have seen this kind of, we have like, training this, and this kind of has been seen many times in the literature. Maybe kind of I can share with you a metaphor, right? So maybe I can do here kind of a speculative analogy to how we as humans train, acquire language. So when you acquire a language, the first language, there's a specific part of the brain where the language capability goes, right? When you learn a second language, what happens? It doesn't go there. It doesn't. It goes in a different place. It goes in a place where capabilities are stored, like how to drive a car, how to hold a pencil, how to run, different kinds of capabilities. And the second language and every subsequent language goes there. It's a capability. Now, if you think of that, well, if I want to learn a new language, well, I probably kind of want to be smarter and I want to have already linguistic knowledge, right? So that I can, basically, we know that a bigger model can pick anything from less data, from less examples, right? Even kind of, you know this even from in-context learning and all that. It's just like more intelligent, right? So, in a way, metaphorically, the new language kind of comes in a different, it doesn't really go in a different place in the parameter space, but in a way, kind of, it's learned as a capability. And if you have, the less data you have, kind of the bigger model kind of you have, so that you can make good use of that data. And now, this somehow relates also to the reasoning part, right? So if you don't have that much data in Japanese, the model is not going to be that capable, right? And then at the end of the day, maybe this kind of reasoning is actually a capability. It's not a linguistic competency. And maybe you do it in the primary language. Actually, we all probably kind of here most of us probably speak more than one language. And for different kinds of tasks and different kinds of thinking, maybe you are better at one language and you're better at, for other tasks, maybe in other languages. If I'm solving a math problem, I don't know, maybe I'm thinking to myself in specific language, maybe my native language is better. So why should we force the model not to use its native language?
Makes sense. Thank you guys for sharing. So it seems like it's still important for the model to learn multiple languages. That's kind of an agreement, because you can transfer the capabilities between languages and the model can become more generalized. And also data scarcity, right? So majority of the data is still English, and it helps us build stronger models when we train on more tokens. So combining English with other languages makes sense. All right, so I'm gonna kind of like switch the topic a bit. So Hrant, I know that Armenia spent a lot recently on investments on AI capabilities, developing your own data centers to build these models. I think it's important to understand, do you think that the Armenian people already see the value from all of these investments? Or how do you envision this happening?
Yeah, so obviously no one sees the value yet because these data centers are not yet running, but yeah, so, to give a context, so I think right now in total, in all companies, universities in Armenia, there could be something like roughly 50, 60 A100, H100 level GPUs. And
How many?
like 50, 60, yeah. And like in January, our university will have another 64. And then in 3 months, one private cloud will have another 500. And then in another 3 months, Firebird will do 6,000. So it's like 100x growth in 6 months, right? So, at that level, it's obviously a lot more than the internal capacity can handle. So, but these are like private companies; they will become neo clouds. So, I mean, everyone in the world can use it. So now the question is how the country should position itself, right? So how to utilize this. So I see like 3 different things, and that's what I recommend to the government. So one thing is obviously the language understanding and the cultural understanding and stuff. And surprisingly, this part does not really require a lot of compute. So I think what the government should do is to start from benchmarking efforts. So there should be a lot of benchmarks that cover all aspects of Armenian that you care. And then have a process of testing, evaluating all the new models from open to closed to whatever to understand what's going on in the world. And then if we see that, I don't know, we want an open model that has this type of capabilities in Armenian that does not exist, then you should spend effort on instruction tuning datasets, which is very expensive and very hard to do, and it does not require much compute unless you figure out how to use Gemini to generate that. And then only after that you come to this post-training. So my recommendation to our government is that you don't need to do pre-training. So just take, according to your leaderboard that you have created for your benchmarks, pick the best one of the size that you want and post-train to get to the necessary levels. And then once you get to that level and you manage to deploy it so that, I don't know, all the schools in Armenia decide to use this, then this compute will be used for local sovereign inference, right? That's something that you don't want to rely on other countries. So this is one aspect. So it will require compute only at really the inference level, maybe a little bit on post-training. And in fact, you could do post-training on other clouds as well. So even if these GPUs did not exist, you could still do this, right? Yeah, so the second aspect is capacity building. So I agree with most of you here that the talent is the big bottleneck. And you have to make sure that every research team in the country has access to compute and is not bottlenecked by compute. And in case of Armenia, you will soon realize that there are more students that want to train AI than there are research supervisors who can actually pose the right problems to spend this compute on. And that's why I'm recommending our government to start a program to engage researchers from other countries that, like, I don't know, if there is a US university that doesn't have enough compute, like I'm talking to a friend who is doing a PhD at MIT, and currently we have more compute than they. So, and like in 6 months it will be...
Congratulations.
Yeah. So, so if they have good problems to solve, so the condition is to work with students in Armenia, so kind of take those students into your group in a way, and so that they work together. There will be some travel funding so that you come, the student comes, and so on, and you get access to some amount of compute rented by the government from local cloud. So this way, I think it's possible to grow the number of people leveraging the research expertise from all over the world, grow the number of people in the country who can use these GPUs properly. And then the third dimension is business, right? So how do you make companies in Armenia more competitive? So there are companies, I don't know, maybe 20, 30 companies who have internal capacity of using GPUs. So one thing that the government can do is to provide them like unfair advantage of subsidizing compute to make sure that those who know how to use compute have better opportunities to do that and be more competitive on the global stage. The other aspect is to make sure that the number of such companies grows. Okay, so there are many companies that kind of think about this, but never ever tried to do something on more than 2 GPUs, right? So they never had the opportunity to try that and never had the kind of risk to take. So it's possible to de-risk those companies by providing them, like, I don't know, one node of compute for a few months and ask them to try waters, right? And this can be also connected to those student pool that was being developed in parallel, right? So maybe some students can come to these companies and bring their knowledge and to try to see what can be done on their internal data or whatever. And then once these companies show that they could do something useful with this compute, then I don't know, you can give more compute. This is like in some sense hard to implement in practice because it's hard for the government to judge who actually needs the compute and how to like navigate these things. Like one idea that we have is that this can be connected to venture investment. So if there is a VC that invested in this startup and it's like claiming that they need compute, so this is kind of a validation for the government that it's worth to provide them some compute. So someone has a skin in the game in the process. Yeah. So I think this with these three directions, it's possible to boost the ecosystem a lot.
Great. So it seems like you hope to see the value for like students, researchers, and businesses that probably like benefit from these innovations that researchers worked on. Yeah, that makes sense. And I think you also mentioned that you recommend the government to not pre-train from scratch, but spend most of your effort on fine-tuning. So my next question is to Rio. So I know that you spend a lot of time trying to see how to transfer knowledge and coding capabilities from English-centric models into the Japanese models. And I know that you found that cultural aspects are hard to transfer. So from your perspective, what's the best for state-of-the-art Japanese models? Is that better to pre-train from scratch on Japanese language, or is it better to fine-tune?
So I think these things are done for different objectives. So if you just want a highly performant model in your own language, then and to develop it fast, then of course you don't want to pre-train from scratch. It's you can, because if you can take an open model, there's very good open models nowadays with Apache license, very easy to use, and you can just add to that, right? And you learn a lot by actually continually pre-training on these things, or fine-tuning, or mid-training, any of these things, because to improve from an already highly performant model, right, you need to have a good data mix of your own, and to be, to not forget what the knowledge that these good models already have, right? So if you naively do any kind of fine-tuning or mid-training on these very good models, a lot of the benchmark scores are going to decrease, actually. And a very few ones that you really focused on in your training set will increase. But it's just a very few out of the whole array of benchmarks that you're running. And so then it becomes a matter of balance, right? Like, so the whole idea of continually pre-training for your own, sovereign AI or your own culture is to optimize for a slightly different objective, right? These huge foundation models are trained for their own balance, what they find is optimal to serve their customers. But what your customers want is slightly different, and therefore you want to shift that balance of your benchmark suite, or your range of benchmarks that you evaluate on. And of course, as you mentioned, so having the benchmarks is the most important thing, right? Unless you can't really improve what you can't see, right? And what you benchmark is what your goal is. But the reason why we try to add on to these open models is because we have slightly different goals, and we want slightly different balances in the data set. And you really see this when you continually pre-train. You really need to be conscious about what you're aiming for. You're going to lose something to gain something that you want, right? There's no free lunch in. And as you said, bigger models can tolerate. You can add more without losing or forgetting much. But there's a limit to this also, right? Like you can only go so big in in a finite training budget. So you do need to be very careful about the data mix that you're continually pre-training on. And so we find this to be the most crucial thing. And this is also something I mentioned, like reasoning in our native language. I think we have not figured out the right data mix that allows this. If we add too much Japanese, the math and code skills go down. All the reasoning benchmarks actually decrease. If we let it reason in Japanese, also, the scores go down. And so it depends a lot on like what the data mix is that we're training on, and we haven't figured that out. Going back to the original question, so the fastest way to figure this out is to do a lot of cycles on, like the downstream side of not the upstream pre-training, but mid-training is less expensive than pre-training, and fine-tuning is even less expensive, right? So to do more cycles on downstream, and then to figure out the right data mix, and then to push that gradually upstream, right? Eventually, what you find as good data, they can be pushed to the pre-training, but it needs to happen downstream and then get pushed back upstream gradually. It's sort of like, the sort of inverse development cycle of pushing the data upstream gradually. So yeah, I totally agree with you that pre-training from scratch without knowing what the data mix is I think is a horrible idea and a waste of computational resources. You should do a lot of tests, and you can figure out the right data mix by actually trying to add more capabilities downstream. That tells you a lot about how good your data is, because unless you have good data, your scores are going to go down if you try to add to a highly performant open model. And because we have a lot of good open models now, we can do a lot of tests without too much compute. And I think this is a very important path to try to investigate what you want to train on and what the right data mix is for getting a good performance. And once you can figure this out, I think you can actually, with enough computational resources, you can actually pre-train a pretty good model once you figure that out.
Yep.
Okay, makes sense. So it seems like that pre-training from scratch might be too much. You can benefit from open source models, but it's still important to do continuous training. It's not just fine-tuning to be able to learn other language capabilities. Makes sense. Do we have anyone who disagrees? Should we pre-train from scratch?
No, I actually just wanted to make a wider comment. I think the distinction is becoming more and more arbitrary between the two. Think about pre-training, what it actually is, right? It's to overcome our difficulties with optimization. So it turns out large volumes of data overcome issues in the stability of how we converge, and so we get to a stable place. But now we have more and more high quality data. Basically, post-training refers, because we do this lower quality unstructured data, everything that follows is just trying to get it back to the distribution we actually care about. You're just trying to steer it back, but we have more and more of this data, and so it's becoming the distinction between the three parts: pre-training, now mid-training, post-training, alignment. It's arbitrary and refers much more to our inability to optimize in a meaningful way, in a coherent way, than it is to the essential need for these to be stages, right? It's hacky that we have them as different stages. And I think that's becoming increasingly, we now have enough data that's high quality where you can see, and our techniques are becoming more and more efficient, where I think you're going to see a lot of these combined. Even the introduction of mid-training is an acknowledgement of that. We're just pushing it further back. So I think that's the fun part, is that these were really hacks, but we developed them as separate disciplines and gave them academic sub-communities, which is odd. Yeah. Yeah, go for it.
Yeah, maybe I want to add something here. So there was kind of the evaluation measures, right, were kind of mentioned as something very, very important. And I have already mentioned that it's important to have those developed really in the target language instead of translating. Of course, translating can be the first thing, but there's another aspect. The aspect is that, well, you can easily overfit on those measures, okay? And the more effort you put into this, the worse you can actually overfit. And actually, these days, okay, before there was mostly kind of SFT, you can overfit to some extent, but it's kind of fine. We can talk about the data mix, but then it starts much, much more dangerous afterwards, because this DPO can get you quite high. Reinforcement learning can be even higher. Can get like very, very fantastic scores on one data set, and then kind of it destroys pretty much everything else, right? So so kind of your distribution becomes very, very spiky. And then there are even more interesting phenomena these days that are happening. So here's what is happening, okay? In many cases where we have some generative thinking, you say, what do I do? Well, I do LLM as a judge. Well, okay, again, measures, let me tell you. So we have like working on something, right? And we had a model, we had another model. You knew that kind of this model was so much better than this other one, right? Let's say on translation, right? Scored with blue. And for some other things, we didn't use blue because we had to use LLM as a judge. And we said, so you know what? It's easier. Let's just have LLM as a judge for everything. Wrong. LLM as a judge is terrible at translation. It cannot tell whether one translation is better than another. It probably can if you kind of tune the model to do this, but LLM as a judge, people just take it and say, it's going to be good. It's not. Kind of, if you have rouge or blue or something, established, tested in the literature, just use that, right? That's one thing. But the other thing is that, those models are becoming now intelligent. And when you do kind of reinforcement learning, you know what happens? They learn how to trick the judge. They overfit. They kind of learn to put some pleasing phrases, to put something there that is going to to trick the LLM as a judge to give it a good score. Okay, that's what they optimize. Just like in the old time, when you have like some classifier, feature-based, it's gonna find, you want to do, I don't know, some kind of classification. It finds, some keyword here and there, this kind of data leak, and it's gonna like exploit like hell. That's what those models are doing. And they're kind of intelligent, and so we really, really have to be very careful, and we have to really, really look into the data. So basically, when we are developing even the first JS, every single important decision was made based on human kind of manual judgments, right? So, and in fact, when we released the first model, JS, right, it was at the time of Llama 2, right? And actually, it was, of course, excellent in Arabic, but in English, actually, we had a capability, we had a model that was maybe a point or two better than Llama 2, right? But we didn't release this model. Why? Well, because each generations were visibly worse than another one. It was like, maybe 1 point behind, right? And we said, you know what? I don't care. I don't care about the ranking. I want a performant model. And we released the one that actually had the lower scores because it was better.
Okay, Hrant, do you?
Yeah, two more small things to add. So I completely agree with Sarah that the distinction between pre-training and post-training and other things is getting blurry. So I think the question in practice is the following. So if Qwen required X amount of compute to train it from scratch till the end, like which percentage of that we should spend to make it speak better Armenian, for example? And I think I agree with you. So we should start with like 1%, maybe like 0.5%. Do it many times, maybe with different data mixtures, different instruction tuning sets, and so on. And once you get confident, maybe you can go to like 5%. And my hypothesis is that you will never need to go beyond like 20%. So I think like you should keep most of what Qwen people are doing, as long as these companies keep releasing those good models, right? So my answer might change in a couple of years. And one more aspect of the benefits of having a pre-training skills in the country is an important one. So that idea was also mentioned by you, right? So it's really good to have this internal capacity, but I think that like in our case, my personal strategy for that is to develop this capacity not on languages. So there are many other interesting modalities on which you can do pre-training. So like biology, chemistry, whatever. Yeah. So, so I mean, the third aspect sorry, I'm talking too much, is that, you know, even if you develop a better Armenian model, no one is going to use it because actually the users are, like the amount of marketing and user discovery and user outreach that OpenAI and Google are doing, it's hard to match that, right? So if you really want like an average citizen to have a better AI that has better understanding in Armenian, you'd rather spend your effort on convincing OpenAI to take some of those instruction tuning datasets that you developed for Armenian benchmarks to put into their training pipelines than to develop your own model, right? So I think that once you have the benchmarks and once you have your instruction tuning sets, maybe invest your political power to kind of convince those big companies to put it into their evaluation cycles, right? That might have a lot more impact on your citizens than develop a model and put it on Hugging Face, and yeah, that's it.
Yeah, Alan, just 2 comments. One right to this, coming back to the capacity of the model. So if you have political power of all countries of the world and they're all trying to ask OpenAI to add instruction data sets into one model, I'm not sure how well will it go. The second comment which I wanted to make is also we need to think about cost of inference. One thing which we've seen with Jace was that we tried initially training model from scratch and adapting from Llama, and at least in Arabic, a smaller model trained from scratch was performing better or on par with the large model and adapted. So it's not only the cost of continual training or whatever adaptation that matters, but also cost of inference, and just need to think about that upfront as well.
Thank you. So I guess like a lot of the discussions that we were having today, we're kind of under the assumption that there is a lot of models available in open source that are pretty good, right? So we can continue developing on top of them. So Kunwu, a quick question to you. What's Korea's perspective on open sourcing your own models? Is that good for your country, for the ecosystem, or is that actually undermining the strategical advantage you can have?
The answer is yes.
There was or.
Right. The answer is that the ecosystem matters way more than this tiny bit of a. So I think the advantage of the collective advantage of the whole nation, whole country, by open sourcing that they can get by open sourcing models, completely override and make it negligible about the small benefit that one company and owner of the model might have because of something that is nicely done at that point, which will remain as their edge for like, I don't know, maybe a year, 6 months, right? So those things, you know. And this is not just my opinion, but also actually an answer about Korean government. Because my answer could be too short, I'll just also use this opportunity to introduce what the Korean government is doing like right now, started this second half of this year, until to the next 2 years more at least. So Upstage is my company is taking part in this competition. Something that some of the components that we already have mentioned here that is already implemented and is being running now. So in this government organized competition, first it's designed by actually AI researchers, because in the new government that we have senior presidential secretary Jung Woo-ha, Dr. Jung Woo-ha, and then the Minister of Science, Dr. Kyung Eun-bae. 2 of them actually were the leaders of the companies in AI research teams in different companies, Naver and LG. Now they set this basically battle royale of AI LLM language models by, as we said, providing some GPUs, funding them to hire more people, funding them to make more data, and also create more data and then provide to the companies in some sense as well, so that they can train good models. They compete each other. By doing so, the whole goal is not to just get one good checkpoint of a model, but to have a whole ecosystem, not the compute infrastructure and the talent and the industry as well, so that the talent will remain encouraged and rewarded. The whole thing, one of the components that I also want to mention is that the conditions is you have to open source your model. And so that's why I told you this is not my answer, but also Korea government answer, that it is really the requirement. And why? Because by doing so, well, I'm part of the team, and that's just better for us, right? That just makes us feel more excited about the whole thing. And by doing so, actually although we are competing to each other, after this first period ends in like a few weeks, we will get to see what other people have done, and everyone will learn from each other, and that will accelerate the progress of the AI technology in Korea, like so I think effectively well. So that's what we are looking forward to, with hopefully the good result for our company as well. Yeah.
So well put. Thank you so much. Oh yeah, Preslav, go ahead.
Maybe I want to mention something that was not mentioned. So we have been kind of focusing primarily on the pre-training, post-training, kind of how you produce those models, but we have not touched something else, right? I mean, at the end of the day, why are we doing it, right? Okay, if you just put it, maybe you put it in Hugging Face, okay? Well, okay, maybe that becomes popular. So, for example, JACE has more than 1 million downloads, combined kind of, from the JACE family. It's by far the most popular one in Arabic. Okay, across the street there was TI. They had like an early Falcon thing, which was like 40 million downloads, right? I mean, you can have things, okay, have an impact for a while, and then it gets outdated, and then what? You train the next one. I mean, but really, and then maybe we have got good scores that are there on the leaderboard, right? Again, if you go in the leaderboards, actually, those leaderboards they get outdated very, very fast. If you go in the leaderboards, the leading leaderboards, the JACE models that are currently there, they are probably not in the top, I don't know what. I mean, they're definitely not on the top, right? But still, they're kind of the most popular one, among the users. Why is that? Well, because there was a lot of overfitting. There was a lot of things. They're so it's, at the end of the day, okay, where's the utility? Okay, where's the utility? How the business can benefit from this? Well, not everybody has a GPU to run it locally. Some people have, some don't, right? I mean, the other thing that you need to think about is, okay, can you have like a national initiative actually to serve this model, right? And to offer something to the citizens. And certain countries have been doing this. And actually, we have been doing that, right? I mean, we have been doing this with now K2 Think, with K2 now, now with JACE, so that, people can actually use it. And then many things that you probably didn't even think about come. Oh, I need a good web search. Oh, I need the one context. Oh, I need to support the dialogue. Yeah, I mean, all these things that you are not really measuring, right? That's one thing. Another thing is that there can be utility in a different way. So, for example, in my whole country in Bulgaria, they created kind of a language model. Okay, maybe it was very performant, maybe after a while not so performant, those things are moving, right? But people are very, very kind of amazed by certain things. Oh, it knows these little, kind of trails in the, in the mountain. Why? Because they collected this kind of information. So, something that ChatGPT doesn't have. You say, I want to go from this part in the mountain to this part. You say, yeah, you go here, you stop there in this hut and, do this kind of things, right? It's really, really kind of local information. So, and it's not about putting it there. And then the other thing is Darak, okay? We didn't really mention this much, but it's really, really important. And, and kind of really to think also, kind of the entire ecosystem, tool calling, agents and all that, right? And kind of how do you support this, as part of the model. And again, if you're just like looking in the language model, maybe you don't think that much about those things. But in the business sense, right, if I want to to use it, the first thing that I need is Darak, something to search in my documents. Only if this is not good enough, then I probably need to go to adapt it to my domain, so I can do some maybe teach the capability, SFT or whatever. And then if it's not good enough, maybe I need to adapt it to my language because it's medical or whatever. I need to do continual pre-training, and only after it I need to go into the one. So Darak is the main thing. And then if you think about it, we mentioned data, okay, about data. I mean, we are out of data. Everything that could be crawled is crawled.
I don't agree.
But there is a lot of data. But there is a lot of data that is not available because it's proprietary. Okay, there's much more data that's actually proprietary. I mean, what is crawled is the public data, right? So and you really kind of need things that are going to enable people to serve this kind of data, get access. But you don't agree?
I just think it's too simple a narrative to say we're out of data because our synthetic data is now much better. And so generating and targeting distributions of interest has never been easier. It depends on the quality of your teacher, right? So this all hinges on can you generate high quality data? But for many areas you can, which actually changes the data space. You can optimize in it. It's more malleable. Self-driving cars has known this for a while, but now we have more tools across domains. What it does mean is it's another reason to have a good sovereign model because languages which are well represented by teachers will become more ubiquitous and poor languages will become poorer. You know, that's what's going to dominate languages. But yeah, I think the fallacy that data is ending is actually an imprecise one. Just because our synthetic modeling methods have greatly improved. For images, it's a different story. Our synthetic data for images is still far from perfect. So I think, and typically what is generated by synthetic models is actually not very diverse. It's very much optimized for human perception. And so it means there's very few modalities that are generated, which is kind of interesting to think about. But I will pass back to our moderator because I think we're low on time.
Yeah. We are closing. Yeah, I just wanted to say that I totally agree with you guys. I think it's important to kind of maintain the dialogue, right? To continue pushing to open source, because one of the problems like I encountered recently is that when Meta released their Scout models, like the Llama 4 model, right? I got a lot of questions from people asking like, what's wrong with their MOE recipe? Why is it so bad? And I have no idea how to answer that because I don't know what happened to their recipe. Was there like the wrong architecture? Or was there something with the data mix? So I think when you push to open source, it's not just helping others build on top, but also community can help you correct your mistakes and we will evolve faster to better models. So I guess to close our Sovereign AI panel, I want to ask everyone to maybe briefly mention how do you envision the world in the future? Are we all going to continue kind of creating this like unified AGI community, or is the world going to be more fragmented with countries focusing on their own sovereign AI capabilities?
To keep it brief, I liked the comment Raquel about competition within the country. So I think we will be better. And also coming back to my earlier remarks, yes, there will be competition. Yes, I think there will be more models rising from different parts of the world, but I think it's all good. We will learn from each other. That's my rose glasses.
Yeah, I don't know. I think I can say that one metric that I'm tracking is the gap between the top frontier model and the top open model. So I think this gap is still manageable, but if it gets too big, it's going to be a big problem for all of us. So it's weird that right now the Chinese models are kind of keeping up and the US models are only increasing the gap. Yeah, so it's like, yeah, I think that that's an important metric to track, and we should make sure that this gap is not getting too big.
Yeah, I'll be very brief. I think that there's fun things happening. I don't think anyone's doubling the size of their model in Frontier AI Labs over the next year, so our architecture is more saturated. Typically, most discovery is discovery, you discover something, you exploit it, you saturate, and then you explore again. And so exploration is very interesting right now because it's about the combination of the recipes. So how do you combine your weight space, and then your data malleable space, and then your exploration space at test time? I think this is fun because it expands the areas computer science should care about, right? So if you're not doubling the size of your model, it's much more interesting how the model interacts with the world, because you can create much more powerful models by taking into account what's being seen. This focus on interaction means that computer scientists who have traditionally not really cared about a malleable data space or about the UI, it will matter more and more. The system matters. So I think that's very interesting. So I think all bets are off in terms of it's going to be fun and interesting over the next few years as we really either discover a new architecture, which is a bit harder, especially since all our hardware is very, very optimized for the architecture that we have. Or we will, the winner will go to who does the recipe the best and who actually gets the most interesting, efficient way of interacting with the world, with efficiency being the key. So fun times ahead.
Well, I think that the landscape is getting fragmented. So initially when ChatGPT came, people thought, well, there's going to be one super model that is kind of performant. And I think that the AGI idea is kind of somehow pushing in that direction. There's going to be this AI that is going to be one and is going to be very powerful. By now it's clear that maybe that's going to happen, but kind of currently things are going in the opposite direction. So the space is getting fragmented. There are kind of models that are being specialized for different things. Even if you go on one of those frontier companies, well, I go in one of those companies and I say, okay, I want to compare to their best model. And for some of the companies, I cannot even figure out what those model is. I don't know, because there's this model for one context, there's this model for this, there's this model for that, there's this model. Why is that? Well, even the companies that are producing the models, they realize that you need different models, right? So because, if you want to have one context, you pay for that. You are kind of less performant short context, right? Even to that extent, right? So imagine one model that's like super at everything, right? So kind of that's something that is going on. So AGI. It's a little bit, we started initially kind of what is sovereign AI, it's much easier to define. What's AGI is much harder, right? And it also kind of, there are journalistic fantasies and this and that. So I would prefer that we focus on things that we can measure. So, and then we can measure success based on that. If you say, okay, I want to achieve X, okay, let's work to achieve X. I want to achieve something great, kind of it is going to be super intelligent. Okay, so how do I know I succeeded, right? I first need to have the measure. Of course, with all my criticism before that, we can actually badly overfit on the measures, but it can be okay, If my measure is I want a good translation system, and if I really, really kind of perform very well on translation and not so well on others, there's nothing wrong with that, right?
Yes, I think disagreement between researchers is one of the big problems that results in this kind of fragmentation. I think fragmentation is good for exploration, and the consensus should be done evidence-based. So we should fragment, experiment more downstream, do more exploration, and then come to an evidence-based consensus to do the common, the shared part. I think so fragmenting is good for, exploration.
Well, besides the future where Upstage wins the competition and Cerebras supporting our models, the one thing I'm not sure it's my prediction or just my hope that, so I'm hoping by lots of sovereign AI and the government side, like funding and accelerating of the AI technology, I hope that doesn't really just benefit those who are already using AI a lot, like me, who pay a lot of money to Cursor, so that they can pay a lot of money to Anthropic. But also like people like, say, my parents, for example, like they spend pretty much like $0 or 0 Korean won on AI so far, which is maybe fine, but also at the same time they are out of the benefit. I'm sure they can benefit a lot by using AI more. Instead of asking me or my sister sometimes. And it's just, it's not balanced, right? And then we are even investing more and more because now in the short term, it's so certain that we will spend more money on coding applications. But think like this democratization of the AI technology, I think will just cover more people and in like regionally in terms of their income, like race, like regardless of those notions. I hope it is just spread more so that more people actually use it and I don't know, find it useful and do things better.
Thank you so much for such an incredible panel and for sharing your insights. Let's give our panelists a round of applause. So any questions from the audience? And Natalia, could you help me with the QA chat? Okay. Yeah, sorry about that. Okay.
One question. Okay.
Shoot. Okay, we have time for one then. You guys heard the question, right? Why do we call it sovereign AI?
Sovereign AI, with every layer below model, right? You have chips, you have go down to the rare earth materials, you go down to the cloud, even the stack, inference stack, right? So these are controlled by a handful of you cartridge, right? So why do we why call it sovereign? What's really sovereign except the marketing here?
A lot of things, I think. Yeah. Right. There's the stack is tall. There are a lot of things, right? But maybe we can see it in the progress, right? It's a status. I don't think maybe someone want to define a sovereign AI with 100% independence. Well, I guess my definition is a little loose than that because I don't know. Maybe right? If all the companies and all the providers of the whole stack is totally against, let's say, South Korea. So no one sells us anything. In that case, I would need to define it in the most strict way so that we really achieve it in our own internal resources. And thankfully, that's not the situation of the South Korea, for example. So I guess that's why it's okay to. I mean, still we want to do it in our own way that is most beneficial to our economy. Now and in the future. And that's why we call it sovereign AI, even if in some part of the stack we are depending on some other countries.
To add, so I don't think sovereignty of the technology is binary. I think every little bit matters. Every little bit that we can do on our own, even if we need to run on foreign hardware, if we have the certain part of the software stack, or if we have certain part of the AI training stack, right? Every little bit matters. I don't think it's not like an either or thing, right? Well, of course, it would be good if we could manufacture everything on our own, but realistically speaking, that's not possible, but we don't want to give up, so, right?
Okay, so I guess we can just close the panel. Thank you so much for coming today.